Okay, so what's the question given? A particle is confined in a one-dimensional box with the boundary x equal to 0 and x equal to L. Potential energy inside the box is 0 and infinite outside. The question asked here is the probability of finding the particle in the middle of the box for the ground state is. So what is the probability of finding the particle in the middle of the box? So there in the question probability is asked, so how to answer it? Listen, you know very well, probability, right, at any point. So now probability is asked in the middle of the box. Middle of the box means x is equal to L by 2. Okay, x is equal to L by 2. So what is the probability of finding the particle at x equal to L by 2? This is the question asked. So how to do that? And you know very well, probability is nothing but since in particle in 1D box, the wave functions are real functions. So psi square will give probability of finding the particle at the particular point. Okay, so here they are asking probability in the middle of the box. So at the middle of the box, what's the probability? So you take square of the wave function at the middle of the box. You know very well, for particle in 1D box, wave function formula square root of 2 by L, this is the general formula, into sine n pi by L into x. Okay, for the nth state. Now since it is a ground state, so we should put n equal to 1 here. So square root of 2 by L into sine pi by L into x. Now what is the wave function in the middle of the box? In the place of x, you put L by 2. So wave function in the middle of the box is square root of 2 by L into sine pi by L into L. This L and this L cancel each other. I'm sorry, middle of the box, no, x is equal to L by 2, I'm sorry, yeah. So put L by 2 in the place of x. So L cancel each other. We'll get sine pi by 2. Sine pi by 2 is nothing but sine 90, right? Sine 90 is 1. Therefore, psi 1 equal to square root of 2 by L and at the middle of the box. Right? Now take the square of the wave function. So psi 1 square will give you probability. So if we take square of this, I'll get the answer as 2 by L. So 2 by L is the probability of finding the particle, okay, in the middle of the box for the ground state. So the correct option for this question is option C. Okay, take note. Question number 2. If h square by 8ml square, if it is equal to 10 electron volt, then the energy gap between n equal to 5 and n equal to 6 states for a particle in 1D boxes. Yeah, it's actually a very simple problem. You know very well, for a particle in 1D box, the energy formula is En equal to n square h square over 8ml square. Okay, then the gap between any two adjacent states, suppose I'll take two adjacent states, this is say nth state and this is say n plus 1 state, right? What is the energy gap between two adjacent states, right? So what we have to do, energy gap delta E adjacent, energy gap between adjacent states, okay, is equal to energy of the n plus 1 state minus energy of the nth state. Okay, if you do some mathematical simplification, you will end up with 2n plus 1 times h square over 8ml square. Okay, it's a very simple mathematical simplification. You can do that. Okay, just use this formula in the place of n, you put n plus 1 square, and here you write the formula as such, then take the common term, then simplify it, will get this. So this formula, okay, will give you the energy gap between adjacent level, and here n is nothing but, okay, the quantum number of the lower state. Among the two, which is the lower state? Okay, this one. Okay, so this gives you quantum number of lower state. In this case, n is equal to they are asking gap between 5 and 6. So lower state is 5. So in the place of n, you put 5. So what we get is the gap between n equal to 5 state and n equal to 6 state. Okay, this gap is equal to, in the place of n, you put 5. 5 into 2 is 10. 10 plus 1. 10 plus 1 is 11. So put 11 times h square by 8 ml square. And the value of h square by 8 ml square is given as 10 electron volt. Okay, in the problem, it is given as 10 electron volt. Okay, so if this is 10, 10 into 11 will give you 110 electron volt. So this is the energy gap between n equal to 5 state and n equal to 6 state for particle in 1D box. Energy of a particle confined in a cubical box of length L is 51 times h square by 8 ml square. The degree of degeneracy associated with this energy level is. Okay, so particle in a cubical box is given. We need to find out the degree of degeneracy. Right? How to do this? Listen, you know very well, for particle in a cubical box, okay, or 3D box, the energy formula, energy depends on 3 quantum numbers, nx, ny and nz, which is given as nx square plus ny square plus nz square times h square by 8ml square. This is the energy formula. Now, the particle has some energy, 51 times h square by 8ml square. So I am going to equate this and this. So the general energy formula is this: nx square plus ny square plus nz square times h square by 8ml square. This is the energy formula. Now, energy for the particle in a cubical box is given, which is 51 times h square by 8ml square. Correct? H square by 8ml, h square cancel each other. So nx square plus ny square plus nz square should give you the value of 51. Okay, so which combination will give 51, that we have to find out. Yes, anyone tell me? You know very well, yes, these quantum numbers can take value 1, 2, 3, 4, etc. It cannot take 0, it cannot take negative number, it cannot take fractions. Yes, tell me now. What are the
711 551?
Very good. 7 7 1 1 one combination, correct? 7 square 49, 1 square if you add, you will get 51. In 711 we have 3 possibilities. What are the 3 possibilities? We have 3 possibilities. 711 is one possibility. 171 is another possibility. Very good. 117 is another possibility. So we have 3 possibilities here. Is this clear to all? It's a very simple one, so I am giving the answer directly. Then, any other combination possible?
551.
Very good. 551. Yes. 551, 515, 155. Correct. So here also we have 3 possibilities. Okay. Any other options?
No, sir.
No. So how many? What's the degeneracy then? Degeneracy equal to
6.
6. So degeneracy of this energy level 51 times h square by 8ml square is 6. It means this energy level has 6 states. Okay, 6 states are there, and for those states, wave functions are different, but the energy is same. So the correct option for this question is option B. Okay, this is problem number 4. A particle of mass m is confined to move on a ring as shown below. So the ring is in the xy plane. And radius of the ring is constant. You know very well, if radius is constant, that means potential energy is constant. We usually assume potential energy as 0. Okay, so assume it as 0. Now the question is, the angular momentum associated with the particle in the second excited level is. Okay, so this is what we need to find out. We need to find out the angular momentum. But listen, the particle is moving on a ring. The ring is in the xy plane. So what is the angular momentum? How to find out? Here, angular momentum, in this case, angular momentum lies on z-axis. Okay, and therefore the z-axis angular momentum, we write z-axis angular momentum operator like this. Okay, LZ operator. Okay, when LZ operator operates on the function phi, right? This is the wave function for particle on a ring formula. If you apply this operator here, you will end up with magnetic quantum number m into h cross into the same wave function phi. Therefore, this m into h cross will give you what is called the angular momentum. So, angular momentum okay, is equal to m into h cross. Okay, if m is equal to 0, it corresponds to ground state. If I put m is equal to plus 1 or minus 1, I'll get the first excited state. If I put m is equal to plus or minus 2, I'll get the second excited state or second excited level state. I'll put level. Okay, so now the question asked here is the angular momentum associated with particle in the second excited level. So in the second exit level, you should put m is equal to plus 2 or minus 2. If I put m equal to plus 2, I'll get 2 into h cross. If I put m equal to minus 2, I'll get minus 2 into h cross. Both these values are allowed. But among the options, okay, minus 2 h cross is not there. And the only option available is 2 h cross. Therefore, correct option for this question is option D. Okay, is this clear to all? So what is given here? A particle on a ring of constant radius exists in a state. Some state is given here. 1 by root 3 phi plus 1 minus 1 by root 3 phi plus 2 plus 1 by root 3 phi plus 3. The average energy of the particle in the state size. In this state, what is the average energy of the particle? Okay, that we need to find. 4 options are given here. Yeah, if linear combination, see, psi is a state which is a linear combination of 3 eigenstates, phi plus 1, phi plus 2, phi plus 3. They are all eigenstates. In this case, how to find the average energy? You know very well. Average energy or expectation energy is equal to summation, okay, Ci square of the coefficient into the eigenvalue. Okay, for energy, eigenvalue is nothing but energy. So what is the energy formula for particle on a ring? It is nothing but ml square h square by 8 pi square I. This is h, I'm sorry. ml square into h square by 8 pi square I. This will give you energy, okay, energy eigenvalue, right? Now, for the first state, phi plus 1, then m value is plus 1. Put m equal to plus 1 here. Plus 1 square is 1 into h square by 8 pi square I. Right? So, for the first function, coefficient is 1 by root 3. So, take the square of that, 1 by 3 into energy eigenvalue for this state. Okay, if I put m is equal to plus 1 here, the energy eigenvalue comes out as h square by 8 pi square I. Then plus, I'll move on to the next one. Here the coefficient is minus 1 by root 3. If I take the square, I'll get 1 by 3 into what is the energy eigenvalue for this state? Here m is plus 2. So if I put m plus 2 here, 2 square is 4. So we get 4 into h square by 8 pi square I. Okay. Then plus, then I'll move on to the next state. Next function, that is 1 by root 3. Take the square of the coefficient. Square of the coefficient is 1 by 3. 1 by 3. Then phi is plus 3 is there. So m value is plus 3. If you put m plus 3 here, 3 square is 9. So 9 into h square by 8 pi square I. Okay. So this sum will give you the average. Now what to do? H square by 8 pi square I is common. So you can take it out because in all the options, see, in all the options we have h square by 8 pi square I. Therefore, you can take h square by 8 pi square I is common. If I do that, here we left with 1 by 3. Here we left with 4 by 3. Here we left with 9 by 3. Okay, times h square by 8 pi square I. Right? Can anyone tell me what is the LCM of this? 14 by 3 times h square by 8 pi square I. So the correct option for this question is option C. Right? Take note. The state of a particle of mass m in a one-dimensional box in the interval 0 to L is given by the normalized wave function. Okay, some wave function is given, it's a normalized wave function, right? If its energy is measured, the possible outcomes and the average value of the energy are respectively. Okay, if energy is measured, what are the possible outcomes of energy and what is the average energy? Okay, yes. How to do this? It's a very simple one. How to do this? See, very easy also. So this is the wave function given. Okay, let me separate the wave function like this so that it will be easy for you to understand. I'll keep this 3 by 5 out into square root of 2 by L into sine 2 pi x by L. Okay, observe this carefully. Plus here we have 4 by 5. I'll bring the square root of 2 by inside. So square root of 2 by L into sine 4 pi x by L. These are the linear combinations given. Okay, and this is coefficient and this is coefficient and this is the wave function. For this function, n value is 2.
Sir, 3 by 5 or 3 by 2.
I'm sorry. Okay, sorry. Thank you. Good. 3 by 5 and this 4 by 5. Okay. So here n value for this function n value equal to 4. If n is equal to 2, what will be the energy outcome for particle in 1D box? What will be the energy? Energy formula is
4n square h square
4h square.
1 second. Energy formula is 4. Very good. 4 h square by 8
Square by 8 ml.
Very good. If n is equal to 4, what's the outcome?
16 h square.
16 h square by 8 ml square. Correct. So these two are the possible outcomes. If you do measurement of energy on this state, you will get either this energy or this energy. Clear? You can simplify this. 4 to 8, if you cancel it, you will get h square by 2 ml square. Okay, and here if you do simplification, 1 8 are 8, 2 8 are 16, so 2 into h square by ml square. Okay, so we get these two outcomes. Okay, I'll just go through the option. In which option we have these two outcomes, you see. So first one is h square by 2 ml square and the other one is 2h square by ml square. So first option, h square by 2 ml square is there, 2h square by ml square also there. So this is these two are correct outcomes. Okay, this is not possible. This is not possible because h square by 2 ml square is there and here we have 8, so this is not possible. And here h square by 2 ml square and 2h square by ml square, so this is also possible. So these and this option and this option are possible options. And what about this? Here we have 8, h square by 8 is there, so this is not possible. Now these two are possible options, but now since they have same outcomes here, we need to find out the average. So what's the average? What's the average? We'll do that. Listen. What's the average? So average energy is equal to square of the coefficient. Here coefficient is 3 by 5. What is the square? 9 by 25. Square of the coefficient into the energy of that level, that is 4 times h square by 8 ml square plus square of this coefficient, which is 16 by 25. Then the energy outcome for this level is 16 into h square by 8 ml square. Now we have to simplify this. Okay, so 1 4s are 4, 2 4s are 8. Here 1 8s are 8, 2 8s are 16. So we get here we get I'll keep the Okay, so if you multiply these two, I'll get 50. So 9 h square by 50 into ml square plus here we have 16 into 2 is 32. I'll multiply numerator and denominator by 2. So 64 by 50 times h square by 8 ml square. H square by ml square, I'm sorry. Right. So now the denominators are same. So add the 2. So we will get 64 plus 9. We'll get 73 by 50 times h square by ml square. Okay, we get average energy like this. So the correct option for this question is option A, right? Take down. If Lx, Ly, Lz are the components of the angular momentum operator in 3 dimension, the commutator Lx, Lx into Ly into Lz may be simplified to. Okay, so components of angular momentum are given. We need to find out this commutator or the simplification of the commutator. Okay, yes, how to do this? Listen, we know very well. See, what's the commutator they are asking? Lx operator, comma, Lx into Ly into Lz. Okay, so how to do this? Listen, I'll keep this Lx as such and this Lx also as such. I'll combine these two and I'll take it as some operator, say A operator, some operator A. So what is A here? A operator is nothing but Ly into Lz. This A operator. Okay, and you know very well the commutator of A comma B into C, A comma B into C can be written as A comma B into C plus A comma C into B. B should be written in the front. Okay, this formula we know already. What is Lx comma Lx? Commutator of same operator. Commutator of A comma A is 0. So this is 0. Therefore, this part becomes 0 plus, and here we have Lx comma Lx into, what is A operator? A operator is nothing but Ly into Lz. Okay, again see this A comma B into C. So apply the formula again. So I'll keep this Lx as such. Okay, now I'm going to simplify this commutator. Okay, Lx comma Ly Lz, apply A into B, A comma BC formula. So Lx A comma B into C, then plus, keep the B outside, A comma C. Okay, now keep this Lx operator as such. Now what is Lx comma Ly? Lx comma Ly is nothing but IH cross into Lz. You know very well. Lx comma Ly is IH cross into Lz, and I have another Lz here. So Lz into Lz is Lz square plus Ly into Lx comma Lz. Listen, apply cyclic rule. Lx Ly is IH cross Lz. Ly Lz, you know very well the cyclic rule. Suppose you take this as Lx, this is Ly, this is Lz. Okay, right? Lx comma Ly is IH cross Lz. Ly comma Lz is IH cross Lx. Lz comma Lx is IH cross into Ly. But now it is given Lx comma Lz. It is in the opposite order. Therefore, you should put minus sign. So minus IH cross into Ly. Okay. So what we get is IH cross, and here we get Lx into Lz square. Okay, here we have minus IH cross into Ly square. Okay, we'll take IH cross as common, right?
Lx was.
Yes, so this Lx should be multiplied here, so Lx. Okay, So Lx, Lz. So now check the options. Check the options.
Option
So
A.
option A, correct? Option A. You keep Lx outside. Okay, so let me show you in the next page. Listen. Listen. So this can be written as I h cross Lx. You keep Lx out, or Lx is common. You take it as common. Then we have Lz square minus Ly square. So this commutator can be simplified into I h cross Lx into Lz square minus Ly square. So the correct option for this question is option A. Okay, option A, the correct option. The correct option for this question is option A. Okay, take down. Is this clear to all? Consider the operator A, which is x plus d by dx, acting on a smooth function of x, some function. The commutator A comma cos x is A comma cos x. To do this is how to proceed. It's a very simple one. Listen. So they are asking the commutator of A comma cos x. Right? Now I'll apply this commutator on some function, some smooth function. Let it be f of x. Okay. And you know very well, commutator of AB equal to A into B minus B into A. This is the commutator of AB. Commutator formula. Therefore, A comma cos x can be written as A cos x, A into B into the function f of x, plus B into A into the function f of x. I'm sorry, not plus, minus. AB minus BA. This is a commutator formula. Okay, what is A operator? A operator is given. A is nothing but x plus d by dx into cos x into f of x, minus here cos x into what is A? A is x plus d by dx f of x. Okay, now we have to multiply this here and this here. So if we multiply here, it is just a multiplication. So x into cos x into f of x. And here you have to differentiate. See, I have cos x and f of x. I have two functions. If I differentiate, I should use what is called the UV formula. Okay, so differential of UV is keep cos x as such, differentiate this, so we'll get df by dx, then plus keep f of x as such. Okay, then you can write f of x as simply f. So keep f of x as such and differentiate cos x. If I differentiate cos x, I'll get minus sin x. Okay, then it'll come over here minus multiply this here and this here. So what we get is cos x. So if I multiply, I'll get cos x into x. So let me write x first. X into cos x into f of x. Then here minus cos x into d differential of this. So df by dx. Okay, up to this, any doubt?
Dx.
Very good. Yes. The first term.
Cos x, f of x.
Okay. So this term and this term cancel each other. Then cos x differential of df by dx minus cos x df by dx. These two also get cancelled. So we left with minus sin x into f of x. Okay. See, we have applied the operator on a function. Right? We got the same function multiplied by some value. So this value is nothing but the commutator. So the commutator for, therefore the commutator for A comma cos x equal to minus sin x. Minus sin x. So the correct option for this question is option A. Right? Take down. Correct answer is option A. Take down. A Schrodinger wave function for a stationary state of an atom is spherical polar coordinate of an atom in spherical polar coordinates r theta phi is some wave function is given a into f function of radial part sin theta cos theta e power I phi, where a is the normalization constant. A is normalization constant. The eigenvalue of Lz for this state is. What is the eigenvalue of Lz for this state? So A is normalization constant, This is radial part of the wave function, and this is theta part, and this is phi part. Okay. Yes. How to answer this? Listen. Now we should find out the eigenvalue of Lz. So take this Lz operator, apply this operator on the function psi. Okay. If you get the same function multiplied by some value, right, that value is nothing but eigenvalue. So what is Lz operator? You know very well, the formula for Lz operator is minus IH cross dou by dou phi. Okay. And what is psi? Psi is given here, A into radial function into sine theta cos theta into e power I phi. Okay. Now see, this operator operates only on the function having the function phi. It operates only on phi. Therefore, this and this part and these are all constants, so you can keep it out. So minus IH cross. Okay, I'll keep all these things out. A into Fr into sine theta cos theta, then differential dou by dou phi on e power I phi. Now we have to differentiate this. If I differentiate this, I'll get e power I phi into I, correct? If you apply differentiation here, right, e power I phi, if you differentiate, you will get same e power I phi, and the coefficient of phi is I, so you will get I into e power I phi. So what we get is minus IH cross A into Fr into sine theta cos theta into I into e power I phi we get. Okay, so this I and this I into I is I square. I square is minus 1, minus of minus become plus, so we get plus H cross into A into Fr into sine theta cos theta e power I phi. Okay, yes, this is the given function. This is the given function psi. So I have applied the operator on the function. We get same function multiplied by some constant. So this is the eigenvalue. So eigenvalue for this state, okay, for the Lz operator, the eigenvalue is H cross. So the correct option for this question is option B. Okay, take down. If the nucleons in a nucleus are considered to be confined in a three-dimensional cubical box, then the first 4 magic numbers are, okay, you know very well, magic number in nuclear physics or nuclear chemistry, you might have seen this. Okay. Option?
Yes, sir.
I don't remember. Let me check. Okay. Anyway, I will discuss. The magic numbers, the usual magic numbers are 2, 8, 20, 28, 50, then 82, then 126. Okay. 126 we use it for neutron. Proton up to 82 is enough. Now listen, these are the magic numbers, the usual magic number. But now, see, here the nucleons are present inside the nucleus. So in nucleus we assume it a spherical body, and we do some different calculation to get this. Okay, but now what is given here is if nucleons in a nucleus are considered to be confined in a cubical box. Okay, then what will be the magic number? Listen, suppose if it is a cubical box, then what is the energy formula? Energy formula is nx square plus ny square plus nz square times h square by 8ml square. Okay. Now, what is the ground level? Ground level, listen, you put nx1, ny1 and nz1. nx1, ny1, nz1. So ground level has one state. It has one state. In one state, you can place the nucleons. See, nucleons have spin, right? It has upward spin and downward spin. So in each state, you can place 2 nucleons. So I can place 2 nucleons. 2 2 protons or 2 neutrons. Okay, then what's the next level? Next level is just increase any one by number by 2. So 1, 1, 2. Okay, this is one possibility, right? What's the other possibility? 1, 2, 1. What's the other possibility? 2, 1, 1. Okay, so the next higher level has 3 states, and in each state you can place nucleon in 2 different ways, with upward spin and downward spin. Okay, so here 2, here 2, here 2. So we can place totally 6. So magic number starts with the 2 first, then 2 plus 6 is 8. Next number is 8. What's the next level? 1, 1, 2. Next level? 1,
1, 2, 3, sir.
Tell me 1, 2, 3 or 1, 2, 2 or 3, 1, 1. Which is having next higher energy?
1, 2, 2.
1, 2, 2 means 2 square, 1. How much will get? 9, correct? 9. So that is supposed to be the answer, right? So 1, 2, 2, 1, 2, 2, or we can write 2, 1, 2, or we can write 2, 2, 1. So here also we have 3 possibilities. In each state you can place 2 nucleons. Therefore here also we get 6. Okay, so 8 plus 6, the next magic number is 14. Okay, then if we move on to the next level, 1, 2, 2 is 9 actually, right? 2 square plus 2 square plus 1 square, you'll get 9. What's the next level? After 9, you can move on to 3, 1, 1, correct? 3, 1, 1. 3, 1, 1 is 9, 3 square 9. So 3, 1, 1, 3 square 9. 9 plus 10 plus 1, 11. 1, 1, 3, 1, 3, 1. Then 1, 1, 3. So here also we have 3 states. So 3 into 2, 6. So 14 plus 6 is 20. So next magic number is 20. Now check the options. In which option we have 2, 8, 14, 20. See? Because they are asking first 4 magic numbers. Okay, we have found out first 4 magic number. So the correct option is 2, 8, 14, 20. The correct option is option C. Okay, take down. Is this clear to all?